Welcome to Novel Ideas, where we chat with local authors. I'm Carolyn Luck, and I'm here with my co-host, Josh Brogadir.
Carol, great to be with you, as always. And tonight we have a special guest, Jess Garrett, who I've known for a while, and I'm thrilled to have you here to talk about your book, Oh, Ick. Don't take it personally. That's the name of the book.
Yes, it is.
So let's just launch right into it for a minute. You were a science educator for a long time, and so you know a lot about science, and now this is one of the most hands-on books that I've ever read. Tell us about it.
Yeah, well, I still am a science educator, actually.
Fair enough.
I love doing science with kids, and I happened to be working at MIT at the time, doing field trips and summer camps for kids, and I met Joy Massoff, who is the brilliant mind behind this idea and also behind two other books, Oh Yuck, which is the encyclopedia of all things nasty, and Oh Yikes was about gross things in history, and she'd been dreaming about writing the hands-on sequel, and she just needed to meet a science teacher who she could write with, and we met, and I wrote some chapters for some textbooks with her, and we started to realize that we could finish each other's sentences, and we really enjoyed working together. And she said, you know, I've been dreaming about writing this book. Could you do the science experiments in it? And how about your husband too, because he's a science educator as well, 6th grade math and science teacher. So, you know, how often does a publishing contract land in your lap? When someone asks you to write a book with them and it's about awesome science, you say yes. So we did, even though we had a 1.5-year-old at home.
You weren't busy.
Oh,
No.
yeah. Well, Jess, I feel like I've known you forever, being a real kindred spirit.
Yes.
I must bring into this my own favorite book from when I was a kid, called Mr. Wizard's Experiments for Young Scientists. There are only 13 experiments in here, but this was just one of my treasures. And when I saw this book, I went, oh my gosh, would I have loved this. And so I was just thrilled to see this and to be able to have you on our show and share some of it with us.
Thank you. Yeah, I'm so excited to be here. And like you, I had books like that when I was younger. There was one that I especially remember called Science Experiments You Can Eat. And I loved doing that, you know, especially the rock candy.
Yeah.
It was really fun.
Although it's funny, so there are 114 experiments, which is a little more than 13, Carol, but
That's true.
of the 114 in here, I love the disclaimer. It says, you know, you have to check with your parents before you do this, and not everything is edible you're going to make.
Yes, do not eat it unless we expressly
There are
say you
acids and
can.
other things.
Yes.
So talk about the idea of, first of all, the age group this applies to,
Right.
and science is something that people think of as fun, but this is really kind of almost silly, some of it, which is really fun for kids.
Well, of course, yeah.
Yeah,
So
yeah.
it's kind of maybe geared towards ages 8 to 12, but I've had 8-year-olds read it to their younger siblings, and they're over in the corner giggling about it. And then my uncle read it and thought it was pretty funny too. So, you know, I think any age level, it's kind of appealing because it's about our bodies. It's about how our bodies work and some of the interesting, perhaps stinky, slimy things that our bodies do. And who doesn't want to know how that works, right? So it's definitely fascinating. You know, it's definitely fascinating and silly. And I think, you know, meeting kids where they're at and getting them to laugh about things is a great way to draw them into science. And then you can actually teach them the science behind it when they're not even really noticing. They're just having fun.
Yeah, well, you have such a great sense of humor that comes through in this book. And I just love even the introduction where you say something like, hey, you. Yes, I mean you. You with the big brain.
Right, yeah.
And you just instantly draw these kids in. I mean, kids of all ages in. And the other neat thing about this book is it isn't just the experiments. There's all sorts of incredible, fantastic facts that you've come up with.
Right, yeah.
The one that first struck me was this robe that was made out of golden orb spider silk that
Yes.
took 8 years.
It's amazing.
Now, where do you find these things?
Yeah, well, you know, first of all, I got to give a lot of the props of the humor to Joy. That is just how her mind works, and I managed to think through how to match it. But I do admit, I really get along with 6th graders and younger because my sense of humor kind of stopped there. So we have a lot of fun just being silly together. And we just did a lot of research. We read lots of books. We kept our ears open to things on the news that we'd hear. I remember hearing something on the news that scientists had figured out that all of us are like Pigpen, the character Pigpen from Snoopy, right? We have this microbiome kind of all around us, a little cloud of microbes, you know, so listening for those sorts of facts in the news, and then doing lots of research even online with educational websites. It's amazing. All the universities have really cool websites that can give you interesting facts about what people are studying, and explain it in ways that are, you know, interesting and available for kids.
Yeah. So this is written with your husband and also with Joy. How does the process work to try to assemble something, whether it was long distance or together? Do you each take parts of chapters? You mentioned that you did some of the photography.
Yeah.
You did some of the experiments yourself to actually put them together.
Oh, we did all the experiments.
Okay.
Yes, every experiment in there was done on our kitchen counter and photographed on our kitchen counter, and often with kids from the neighborhood, you know, or some of my older neighbors too. Bring them in, and they said, "Oh, I wish that I'd done this as a kid. I would have loved science." And so we together kind of came up with ideas. It was going to be an A to Z guide, and so then we thought, well, okay, so for A, what do we have? Oh, acids and bases, arachnids. All right, how about B? Blood, bacteria, boogers, burps. There's a lot in the letter B, you know. And go down the line, T for toilets. Oh, we forgot P for poop. Yes, we get that in there, and F for farts. And all the way to Z, we've got zits and zaps. And so, you know, we had to think of some topics for almost every letter of the alphabet. And then we'd chat with each other about, well, what ideas do we have? And Ben and I would think up, okay, well, what experiments may we have done as science teachers before? What experiments did I work on at MIT? And then we'd do other research too to try and figure out some ideas. And sometimes we just sit down and think, well, how could we model this? Maybe we could make a model of our nose using hollowed out French bread. And then we could pour honey into one and not in the other, and then we could blow some cinnamon and sugar into both and see which one catches more of that, just like the mucus in our noses catches dust. So we kind of think up unusual ways to show things.
Yeah, I was really impressed with the book because the science is so correct.
Oh, thank you.
And it's very, very hard to take a scientific concept and simplify it enough so that kids can understand it. And too often what I've seen happen is people just sort of squish around the science.
Right.
And it's not quite true. And you did such a fantastic job on this.
Thank you. I worked really hard at that. That is, I really appreciate that you noticed that, because I really did. I went line by line to be sure that we were being correct about the science, while also trying to make it easily understandable.
Yeah, one of my favorite analogies was the scab.
Yeah.
You talk about that one a little bit.
The spaghetti scab dinner.
Yeah.
Yeah. Well, you know, when you get a cut, you know, your blood comes and platelets come in to clot your blood, and so, and then there's lots of other bits that come in and eventually sort of squeeze it shut, you know, sort of contract. And so we thought, how can we demonstrate that? So we actually used pasta, because when pasta dries out, it actually contracts a little bit. And so we thought also it'd be really fun for kids to make a spaghetti scab dinner for their family, something they could eat. But meanwhile, they could be like, oh, these little cherry tomatoes, those are our red blood cells. And oh, this mozzarella, this is our white blood cells. And, you know, and now after a little bit of time, it's all going to contract and form a little dry scab. And so we could leave one plate aside to watch that happen, and the rest the family could eat for dinner and be a little bit grossed out, but you know, they made dinner for their family.
As we look at this, and you can probably take a closer look, I mean, so what's cool about this is it explains the experiments, but also has great pictures and photos of things, and some of the drawings, and it's all this green kind of scale to it, which I kind of like. It reminds me, though, when I go through this, I mean, I always like to kind of do experiments, and I think a lot of kids do, but I didn't have that kind of, okay, science is part of my life. Both of you, by the way, clearly do.
Yeah.
You're kindred spirits in that regard. How did you get interested in science? When did you know, and what age that you said, science is what I want to do?
I am not totally sure, but I do have a memory of in kindergarten, 2 science performers came to my school. They were named Mr. and Mrs. Fish. they were dressed up like sea creatures, and they came to teach us about the ocean. And I remember thinking, they are cool, and I would like to do what they do. And it's really wild because all these years later, now I go to schools and I perform, and I talk about farts and boogers and slime instead of fish, but it's just really funny that now I get to be a science performer like them. So maybe that's a piece of it.
Yeah.
My father's a geologist, so he always had me out on field trips looking at interesting rocks and whatever organisms we saw along the way too. And my mom's an artist and a writer, which helped me out with writing, but she also loves science as well. So in my house, it was always a thing that was loved. So you know, I would always go out and explore. And then I was lucky; I had great teachers. And I recently got to see one of them, Mr. Roy. He used to come into my school from 3rd grade to 5th grade. He would come in every day, not every day, sorry, once a week, and he would do a hands-on experiment with us. And I remember just thinking he was so cool, and the science we did was so fun. And so it's so great I got to run into him and say, you made a difference for me. You're part of the reason why I went into this.
Is that meaningful?
Yeah, it's really, really meaningful. And then other teachers too, like if Mrs. Brown is listening, she was my 6th grade science teacher, and she helped me love it too. I remember going to the meteorology station in the room, and I thought I might want to be a weather woman at one point too. So there are lots of people along the way who helped inspire me. I even had a science teacher named Mr. Blood. So what you gonna do?
Perfect.
Oh, wow, that's awesome. Well, actually, we're just about out of time for this segment, but when we come back, we'll have an opportunity to actually play and do some of the fun stuff in this book.
Great.
That's right.
So,
Done a lot of tell. Next is the show.
Excellent.
Yep.
Stay with us. We'll be right back.
Yeah.
Everything starts out small. I love my brother. I know it's not always obvious.
Oh, wait, stay there. You look good. Okay, ready?
The things I say to him and the things I do for him are small and ordinary. But you see, the things that hurt us, they all start from somewhere. A picture, the words we say, the things we do. And that picture, those words, they can grow into something else. What was small and innocent can become big and sometimes scary. All it takes is one comment, one picture, one video for something to catch fire. It's not until it hurts, until it looks like a big problem that we can finally see it. And when that happens, it can feel hopeless. But a big problem doesn't need a big response. Not at first.
There's a hope that's waiting for you.
You see, good things, just like bad things, can start out small. One person's response can change everything. Their actions can catch fire and cancel out the bad. Act when you see something. Even if we don't know what to say, the eye emoji can be that first step we take. Let's all pledge to take that first small step together and change the world in a big way. I am a witness, and so are you.
It takes less than 1 minute to find out if you may have prediabetes. You can do it here. But you probably won't. You're busy. Kids, work, show coming back in 48 seconds. So let's do this now. Hold up 1 finger if you're a man. Women, 0. 3 more fingers if you're over 60. 2 over 50. 1 over 40. If you're not sure, keep in mind you're sitting on a couch right now, so 1 more finger if you're not very active. 1 finger if yes, 0 if no. 1 yes, 0 no. Next, find the body type that looks most like you and hold up that many fingers while I look around awkwardly. And that's it. If you're holding up 5 fingers or more, you probably have prediabetes. Sorry to be so blunt, but hey, you're busy. Just go to the site.
Welcome back to Novel Ideas. We're here with Jess Garrett, and we're going to show you, beyond just telling you, about OIC. These are experiments that are safe for the studio, by the way?
We'll see.
Okay. No promises made.
We might get a little cracked up
Oh,
here, so yeah, things will get a little messy.
Idea. All right. So what do we have going on?
So we are going to flip to the back of the book. We're looking at yucky yolks. And, you know, I personally love eating eggs. I think they're delicious and yummy. But some people think raw eggs are pretty gross, right? And a rotten egg, you would definitely say oic.
Yes.
Right?
Sure.
And so we're actually going to look first at some elderly eggs. We're going to see what happens when eggs age. So every egg, no matter what color it is, has this nice shell on it. And this shell actually has some tiny, tiny little holes in it called pores. And air and moisture can come out of that or go into it. So moisture over time, as an egg gets older, moisture starts to seep out just a tiny bit and air starts to seep in. And that's actually important for the little chick inside. If this were fertilized, the chick actually needs some air to come in. But if we have an unfertilized egg that's ready for us to eat, if we let it sit around for a while, more and more air gets in there. Another thing to know about eggs is there's a little membrane. You may have noticed whenever you crack an egg, you may have noticed at one end or the other, you may see a little membrane. So it's like a little sack, a little bag around the squishy parts of the egg. And so as air seeps in through those little pores, it actually creates a little air bubble in between the shell and the membrane. And so over time, that air bubble can get bigger and bigger. And so what we're going to do is we're actually going to test out these 2 eggs. The color doesn't matter, we just had 2 different ones, but we'll see. This is actually a fairly recent egg that I bought about a week ago. And we're gonna put it in this jar. And you can see that it's kind of lying on its side. There's a tiny bit of a tilt up at one end, but it's mostly lying on its side. All right, so there's a tiny bit of an air bubble in there, but not much. Now we're gonna put this guy in here. We're gonna see what happens. Let's see if we can get a good look at it. See, it's actually standing on its end. It's standing on the very tip.
Yeah.
And floating right up there. So this is about a month old, this egg. All right. And if your egg actually fully floats, you do not eat that egg.
Yeah.
So this is how you can tell if you have elderly eggs or eggs that are a bit more fresh. You just put them in a container of water and you can see if they kind of start to float at one end.
Wow. And kids can obviously do this at home.
And kids can do that at home.
Sure.
Help their family out and make some omelet for dinner. Nice. Now, of course,
Use this one.
if we don't want to eat the egg, we can actually do some more science experiments. And here I have got some eggs. What we're going to do is, I'll take one of those eggs.
Take one of those.
You want one of these?
Yeah, sure,
Okay.
one of those. So we want to have a closer look at that membrane that I was mentioning. So what we're going to do is actually dissolve off the shell. And actually, you know what? I think a brown egg will show this a little bit better. So here's a container of vinegar, and we're going to drop that egg in there. And if we look closely, you can see right away. Check those out. See those bubbles?
It looks almost like a little cloud up there.
Yeah, so bubbles are already forming of gas, and that's rising up to the top. And so what's happening in there is a chemical reaction. So the shell is made of calcium carbonate, which is nice and hard in that shell. And then, of course, vinegar is an acid, right? Acetic acid. And so that acid is starting to dissolve away the calcium carbonate. The calcium and the carbonate separate, and the carbonate joins with some oxygen and forms carbon dioxide. That's a gas we all know about. And so that is carbon dioxide gas rising up away from that eggshell.
Nice.
Yeah. And over time, more and more of that eggshell will dissolve away. So you can actually see, I've got some eggs that I put in there yesterday. Their shells are really starting to dissolve. And then I have an egg that's been in there for a couple of days. Would you like
I'll
to do the
honors.
honors?
Yes.
All right, we're reaching in. Careful, careful.
Whoa.
I have the paper towels. Now this is a squishy egg.
That is squishy. Oh, check it out.
See pretty well that this egg is
Yeah.
Keep
totally
it right steady
soft.
there, Carol. We'll get it for you.
Yeah.
Totally soft.
Yep. And it's really fun even to squish it from this end too. Look how squishy that is.
But it won't explode? Or if you really squeezed it, it would?
Oh yeah, if you squeeze too hard, this will splat
Yeah.
everywhere. Yes, yes, that has happened.
Fair enough.
With some of my young friends. There you
Oh,
go.
wow. It's very cold.
It's been in the fridge.
And I can take a bite? Oh,
I wouldn't do that.
just check.
This
Just
is,
check.
and I had to crack up laughing when I read this part in the book, because many years ago my son did this, and he thought this was the coolest thing, and left the egg in this condition in our mudroom for a couple of weeks, I think.
boy.
And I walked in one day and I said, "What is that awful smell?" To which he replied, "Oh, my eggs." And I said, "Get rid of them." Totally forgetting that I should have been more explicit. He threw the egg down the drain. Well, my husband comes along. I said, "Oh, the kitchen sink drain is clogged up." My husband says, "Not to worry. I will add some Drano." Well, Drano is this very strong base. Well, the Roto-Rooter guy, several hours later, is saying, "What on earth did you put in this drain? It's like soap." So be careful how you dispose of these.
Okay.
Keep your eggs in the fridge, and then when you're ready, put them in the trash or the compost. Yes. All right. So,
next
and you
up.
can see this egg is nice and plump, right?
Yep.
There's lots of liquid in it. Okay. So now we're gonna have even more fun with our eggs,
All right. Bring these
and we're gonna make what I like to call eggs from Mars. So I took one of these eggs and I put it in this container that has corn syrup in it. You can see it's really slow moving, especially at the bottom. I added some green food coloring because, you know, awesomeness
Gotta
of
see it.
green, right? And then I put this egg, it looked like this egg, and I put it in overnight into this corn syrup, and look what's happened. It's kind of strange.
Looks like a
to me.
beanbag.
It looks like a beanbag, yeah.
Or like when you have a ping pong ball that has a dent in it.
Right,
Kinda.
right.
Oh, but it's soft.
And to me, it looks
Yeah.
like an egg you might find on Mars, like an alien egg.
It is.
Right? And here's what happened. So remember this membrane I talked about? So air and moisture can move in and out. It's called semi-permeable. It's partly permeable. So air or water can move in and out. It allows some things to move in or out, some things not. So if you put it in some corn syrup, the corn syrup has so much sugar in it. So it's got basically a lot more stuff than is inside this egg. And water, when you have two things that have different concentrations, different amounts of stuff in them, water tends to move to one or the other to try and balance it out. So the water from this egg moved out through the semi-permeable membrane and into this corn syrup, and so you end up with a deflated egg. Now this has only been sitting in this, for a day, but leave it in there for several days and it'll be even more fun to look at. So have fun with this.
Nice. We're going to stop with the eggs for a minute and go to something else.
Yeah, something else squishy. So now we're flipping to the letter Z, and we're going to do something else squishy that has to do with zaps. And so we're actually going to play with electricity. And this is an experiment that I got permission to use from people at the University of St. Thomas. They came up with this idea, and I just think it is so awesome. So it's not exactly gross, but it's squishy, which is really fun. And so I'm going to give you each a piece of Play-Doh, and I bet you didn't know that Play-Doh can conduct electricity.
I did not.
I didn't know that
Isn't
either.
that
Flatten
so
it out
cool?
for you?
No, roll it like a little snake like
I
that.
got it, yeah.
Yeah, there we go.
Cool.
All right, and you can plop it down on the table. And the thing is, Play-Doh contains salt, and so that's what helps it conduct electricity. But maybe you don't believe me, so why don't you go ahead and plug in the battery.
Okay.
So one in each of your blobs. Yeah, great. Okay, so we've got a power supply now. We've plugged it in, but down at the other end, we're actually gonna plug in one of these little guys. This is an LED, and it's a light emitting diode. It needs very little power. Now, this is interesting. It's not working. So there's something special about LEDs. They actually work like waterfalls. Like water only falls in one direction,
Right,
right?
sure.
So they only work in one direction. So take it out and plug it in the other way.
And there it is.
Ta-da! You made it light up. Excellent.
There we go.
So this is plugged in through this Play-Doh, and so it's really easy for kids to start playing around with circuits based on, just using something like Play-Doh. And check it out, if I touch the two blobs together, I've created a short circuit. Because the electricity is like, I'm not gonna bother going
Wow.
through that LED, I'm just gonna go straight across
Yeah.
through myself. So you can learn about short circuits. And then would you like to pop in an LED as
I
well?
would. Any other spot is
All right,
fine?
so any other spot, yep.
Okay.
And if it doesn't work, just turn it
Turn
around.
it around. Whoa.
Nice.
Ooh.
All right.
really
So
cool.
we're actually starting to get a parallel circuit. Would you like to put one more in?
Sure.
There we go. So we got a parallel circuit going on
That one seems
here.
brighter. I don't know if it is.
Yeah, the green is pretty darn bright. And then
One more?
that's one of my special LEDs. Check it out.
Oh, it's blinking.
Yeah. So that's got a little chip in there that makes it change color. So those are super fun.
That's really cool.
Wow.
Yeah. So kids can start to play around, and adults too can learn about how circuits work. And here I've got another example of, so this is a parallel circuit. If you plug this in, you want to go
Right,
ahead and
yeah.
plug it in?
Okay.
I've set it up a little bit differently. So this is more how holiday lights often work. This is a series circuit. And this is why if one bulb breaks, your
The whole thing goes.
chain goes down, yeah. So 2 different types of circuits, really fun and easy to play with.
Wonderful.
With Play-Doh.
Jess Garrett, a million thanks for coming in tonight. Her book
My
is
pleasure.
Oh Ick. You can get it anywhere you get books, as everybody knows. And we really appreciate the time.
I had fun.
Yeah, thanks, Jess. So did we. And thank you, Josh, my great co-host. And thanks to all the folks here who made special accommodations for us this evening to be able to do our little demos. And I would like to thank our viewers for joining us, and we'll see you next time.
Novel ideas.